There we go. People who already took the EOC, you'll be able to confirm that this is on there because you will have seen this before.
That's what it's called.
Oh my, she doesn't even know what it's called.
So this will help you get a few questions right.
Curly or at the top.
Really good.
There we go. Sequences. 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 What is a sequence? Just in, not necessarily in math, but just in general, what is a sequence?
A pattern repeating itself.
Huh. Pattern, well, I don't know if that's exactly right, but a sequence of events they don't have to repeat.
A sequence of events.
Okay, like in a sequence of events. It doesn't have to repeat. It doesn't have to repeat.
Triangle, like that.
Yeah. Like, yeah.
That's a
Repeating
pattern.
itself.
Pattern. Okay, a sequence could be a pattern.
Repeating itself.
That's so crazy.
Repetition.
Just so stuff.
Oh, repetition.
Yeah, I'm just saying it doesn't have to repeat.
Oh.
Like my sequence of, I woke up this morning, I brushed my teeth, I got dressed, I ate breakfast, I drove to work. Nothing repeated, but that is a sequence of events.
But you do it again the next day.
Exactly.
So that's a
But that doesn't make it a, the
Yeah, it
fact,
does. That makes it a routine. When you do
that makes it a routine. A
What's the
sequence
difference?
does not have to repeat. Okay, let's not get hung up on that. Anyway.
Yeah,
Like you were saying though, triangle, triangle, star, rectangle, triangle.
That is so like kindergarten.
Yeah, that's like kindergarten. We're going to do sequences with numbers.
1, 1, 1, 1, 2, 2, 1, 1.
So here's one, here's a sequence.
Like a computer.
1, 2, I put commas in between them. 4, dot, dot, dot. The dot, dot, dot just means it continues. What would come next?
5,
7.
Oh.
Oh. 8.
But really, what would come next?
Oh,
5.
5. Keep going. Give me the next 4
8, 9.
numbers.
10, 11, 12.
5, 6, 7, 8. Anyone have a different answer?
21.
7, 8,
That's
6,
real.
5.
Okay, it could be 5, 6, 7, 8, right?
It has to be.
4,
No, it doesn't.
5.
What's another answer that could work for this?
8.5.
1, 2, 3, 4.
1, 2, 3, 4. What if it went 1, 2, 3, 4, and then went 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4? Couldn't have been that.
Oh, yeah.
That's a sequence of events.
3, 4, and 3, 2.
3, 2, 1? Okay.
They add up.
For math, we're doing what's called arithmetic sequences first. Remember this, Kayla? No.
Arithmetic.
Oops, you can't see that at all. Arithmetic sequences.
Arithmetic sequence?
That actually says arithmetic.
Didn't we argue about that?
We did, yeah.
I remember.
Okay.
Arithmetic?
It says arithmetic. We are going to do arithmetic today, but this is an arithmetic sequence. I don't know. Don't argue with me. I didn't make that up. That's just, that's how it goes. This means 5, 6, 7, 8 would be the correct answer. You're going to add the same thing every time. So if it goes 1, 2, 3, 4, we're just adding 1, aren't we? So it'd be 5, 6, 7, 8. That is an arithmetic sequence. So here's another one. And what comes next?
4, 6, 8, 10.
Oops, I guess I should have written the definition of arithmetic sequence. What would be next? 2?
2, 0,
0, and then?
negative 2,
Negative 2.
negative 4,
What are you doing every time?
going back to,
Going back.
Subtracting 2.
Subtracting 2, right? You're just subtracting 2 every time you move over to the right one. Right? Pretty simple, right? Keep saying right.
right?
I get nervous
Yes.
when the video's on, and then I start like thinking about what I'm saying. And,
I think it's weird that they're just gonna like hear voices and
Hi.
So, yeah, now I forgot what I was going to say. Too nervous about this video action. I'll get used to it. Oh yeah, the definition of arithmetic sequence. We want to write it. It's just a sequence where you add or subtract the same number
Did you say that in the
every time you, for each new term. Add or subtract, because isn't addition and subtraction basically the same thing? You could just say add the same thing, because you could add negative numbers. We'll say add or subtract. Add or subtract. Geez, I'm doing terrible. The same number to create each new term. Any words in that definition you don't know what they mean? What's a term?
Stuff. Are you talking to me?
Yeah.
I don't want to make myself sound stupid.
It's alright. Anyone know what a term is? What's that mean, each new term?
Number.
Yeah, it's just each number. The terms are just, these are all terms. That's a term, that's a term. It's just, like that would be the first term, the second term. Right, first term. That'd be the second term, third term. These are all terms. Term's a weird word, but it's just the numbers in the sequence. Those are the terms. Okay? Let's look at another one.
They're adding through.
Am I adding 3?
Yes. You're multiplying.
Oh. Multiplying
No.
By 2.
by 2?
Not like.
Add or
You're
subtract.
doubling them, like 3 and 3 is 6, 6
You
and
double
6
as
is
you
12.
go.
Those are being doubled, aren't they? It's multiplying by 2. That is
Oh,
not an
okay.
arithmetic sequence.
It's not.
Remember the name of that one, Kayla?
I was thinking about it. What?
What?
The sequential.
Nope.
No.
You'll find out.
Not.
It's not arithmetic. Right, because the next one would be 48, 96. You're not adding the same thing every time. It's not arithmetic. We will do these in a couple days, tomorrow or Wednesday. Today we're just going to worry about arithmetics. What?
So then what is it?
It's geometric.
Um,
We'll talk about geometrics, like I said, tomorrow or Wednesday.
Why is this useful?
Huh?
You do
He
say
said, why
things
is this
like
useful?
Because
Right,
you're
that's
low.
what you're saying, right?
Exponents?
Yeah.
Oh yeah, you're on the right track. Stay tuned Wednesday. Here's another one. 5 and is it arithmetic?
No.
What would you even be?
Well, you add three.
Yes.
No.
Maybe. I forgot what that means.
Yes, no, maybe?
Yes.
Yes.
Yeah.
In arithmetic,
Yes.
you're just adding or subtracting the same amount every time.
Oh, yeah, it is.
It's adding 3 every time, right?
It looks
Okay.
wonky to me.
Well, now what if I ask you,
It looks
what,
wonky.
this is adding 3 every time. This is the first term, the second term, the third term, the fourth term. What would be the 100th term?
Oh,
Um,
You do the number
you-
times.
14, yeah, 14 times.
14 times 100 divided by 3.
3 times
Just
100.
kidding. 300.
14 times 100. No.
Why 14?
No, 14 times 3, 30.
You're trying to create, what are you trying to do here?
Create
Oh, no.
an equation.
Create a rule for what's going on here?
Sure. I would say not.
So if we want to predict terms like the 100th term, or I could ask for the 50th term, or I mean, if I ask for the 5th term, that's easy, isn't it? It's like, oh, add 3, add 3, add 3. Oh, it'd be 17. But what about, let's try to figure out this 100th term. To do that, we better be able to find a rule. Well, how could we find a rule for this, do you think?
X
3
plus
times
3.
3
Do
times,
like 50x plus whatever the
No,
term
because
is.
then you had all the 30, 14 times 30 and 30.
what?
What?
hey,
Ah.
Kayla had a scenario.
You want to figure out the 50th term? Why don't you do like 50 times however many you're going up by,
3.
plus the beginning term.
Yes, that's it.
What?
Does this sound familiar?
No. No, my brain hurts.
You've actually done this before.
I've seen it before.
I've done it wrong.
Yeah, I've seen it.
We're gonna write a rule, right?
We didn't-
What kind of rules have you only worked with? I'm not gonna ask you to do something
No, so.
that you have no idea how to do.
Um,
Have we written rules before in this class?
No.
written rules.
Written rules for things or equations.
Yeah.
Written rules. for-
Whoa, when have we written a rule or equation for something?
When we do equation.
Last week. Oh, that's right. Was last week.
Nobody
What kind of
ever
rules
looks
did
like
we
that.
last week?
That's over camera.
I thought it might work.
We should upload
Makes
it
it
now.
sound like you guys are smart.
You could be famous.
Oh, we found the slope of lines, and then we wrote the equation for the line.
I don't
Yes,
know who you're trying to.
very good, Anaya.
Yeah, why are you trying to We do not sound like that.
Doesn't sound like anyone.
We found the slope.
I think we should put it on Sesame Street.
What?
And didn't we find the slope? If we know 2 points, can't we find the slope of something? The slope is just how much it changes. You realize that? Finding slope is kind of like just finding the difference between these. You're like, oh, it just adds 3 every time. You want a graph? Let's say we had a graph. Let's say the first term. We'll call these the terms down here. The first term is 5, so we'll be up at 5. We had a dot. And then the second term is a 6, 7, 8. We'd have a dot. And the third term, the 11. 9, 10, 11. We'd have a dot. Aren't these going to be in a straight line?
It's 3 over 1.
Yeah, it's up 3 over 1. That's all that is. That's the slope. It is that. It's the change in the value of these numbers every time you move over one term. Or rise over run. The change in y over the change in x. Here the change in x is always just 1. Because you're just moving over one number. Alright? So what's the slope of this sequence? We don't really call it the slope though. They like in that book that you're supposed to get, they called it the common difference. We can call it slope. We don't need crazy numbers. So what is the common difference or the slope? It's 3, right? You said 3 over 1. Well, how do we write an equation for a line?
Y equals mx plus b.
Yes. This is going to be very similar to that. The only difference is we're not going to use y. When you get the EOC and they talk about sequences, they're going to write this. They're going to write A of n. A big A with a little n.
Yes.
I saw that. I
Oh
got
my
that wrong.
gosh.
You hate that.
Yes. N is the number of the term. So like this is the first term, the second term, the third term. That just means n is 1, 2, 3, 4. So when I ask you what is the 100th term, that's like saying what is A of 100. The A is just like saying, it's just like the name for the sequence. This is sequence A. You could write B of A, but they usually use A. It's kind of like, you could almost think of it as, on a graph, the Y. This would be the A's, this would be the N's. The N's would be 1, 2, 3. The A's would be the value of these numbers. So when we're writing these equations, it's the same thing as y equals mx plus b. We need our slope, which we said was 3, right? So it's going to be 3 times n plus, what is our
1.
y-intercept or our
5.
starting value?
50.
Okay, you say 5. 3n plus 5. You think that's our rule? Let's check to make sure it works. Which term is this?
1.
That's the first term, isn't it? So if I do a of 1, meaning I plug in 1 for n, I should get 5, right? 3 times 1 plus 5. 3 plus 5. I got 8. Oops, I'm getting ahead of myself. I got 8. Didn't work, did it?
Do you have to start at 3?
It gives you the second number.
Yeah, the first term is not where you started. It's not the y-intercept or this. So this part right here